The previous video noted how chainages are generated by measuring outwards from a reference source. This requires that the track lengths be consistent, and this video shows some tools for making this work in more complex situations. A common example is passing loops. We see here in scale view that the top route is longer than the bottom route. While the curved track will legitimately be slightly longer than the straight track, the lengths entered should actually be the difference between start and end chainage of each track. In this case, the default 100 meter lengths suggest that a designer may have forgotten to enter the track length, giving a very large disparity. If we go into chainage view, we can see that this has led to a point with two different chainage values. This is an indication that something is wrong. All routes between 2 points should be the same length. This is easiest to fix in scale view. Because we can see the required lengths, we simply edit the track lengths to make them consistent, and this solves the problem, as can be seen in the chainage view. Another common situation is when tracks need to join an area of well-defined chainage. In this case, the lower track has just been added and we want to know the appropriate length. First, we split the track and look at its chainage, 685 meters. We could just look at the values and subtract. 685 minus 600 means that the track must be 85 meters long. However, the numbers aren't always so convenient, so we can use this tool. Firstly, check that the nodes one track away are reasonable. If these are inconsistent, then the tool might not offer any options because it can only change the lengths of the directly connected tracks. The minimum and maximum chainage offered are based on the chainages of the nodes one track away. This is because the tool will be adjusting the lengths of the track and the length can't be negative. Enter the required chainage and the track will now be the correct length to join to the rest of the track network.